Chapter 15, Think and Rank. Problem 43. 3 metal blocks, same temperature, are placed on a hot stove. They give the specific heat capacities listed. Rank them from how quickly each warms up. And again, specific heat is the amount of energy it takes to raise a particular mass, a certain amount of mass, a 1 degree Celsius or 1 Kelvin. And so steel takes 450 joules. If I have a kilogram, they don't specifically say it. We have to assume that all the masses are the same, because otherwise it's not enough information there. So steel takes 450 joules per kilogram degree Celsius. So if we have 1 kilogram of steel and I want to raise it 1 degree Celsius, it's going to take 450 joules. Aluminum takes, for the similar size mass, takes 910 joules to raise it a degree Celsius, and copper takes 390 joules per kilogram degree Celsius. And so if we're looking at those, copper takes less energy to raise the temperature, and so copper should heat up faster. Steel should be next, and aluminum should be the last one. It just takes more energy to change it, which is why aluminum stays cool longer. There's some also aspect of how quickly does it give up heat, which is it's a slightly different topic. We do also make the assumption that they're not reaching the melting point. Steel melts at 1,370 degrees Celsius, aluminum at 660.3 degrees Celsius, and copper at 1,085 degrees Celsius. We just have to assume it doesn't hit the melting point. And then 45, the precise volume of water in a beaker depends on the temperature of the water. Rank from greatest to least the volumes of the water at these temperatures. And this goes back to, there's a graph on page 295, or chart, yeah, graph of 295 about volume versus temperature. And you see at 4 degrees Celsius, that's when it hits the bottom. That is the smallest volume. 0 would be next, and then 10 would be next, just basically looking at the chart. There's really not a huge amount of difference there, but there's enough of it to answer this question. And so this is sort of re-emphasizing the fact that ice, which is 0 degrees Celsius, tends to have more volume than cold water around 4 degrees Celsius, and so that's one of the reasons ice floats. Less density, greater volume, less density. And that's it for Think and Rank.